So we can continue, and this time now I want to deal with the devices, the digital input, digital output, analog input, analog output. So we're going to have that. I'll create new circuit. And from your side, please try to do the same. So we're having the Arduino as usual. This time I would want to start with the digital output to make it easier for us to understand what's happening, because it's very simple, this one. Make sure you connect it there, then you connect it through a resistor. I remember we said that resistor is one of the most important devices as well, which we use to limit the amount of current. So we have 220 ohms there. So 220 ohms. And then you connect that to ground. You have it as black. So please connect your circuit that way. After connecting, you go to the code, then text. So please take note of what I've done. You click on the code, like that. Then you click on blocks, text, continue. And I think I can as well eliminate everything so that you guys will start afresh. That way you understand what's supposed to be done. And avoid setup. You need to declare the pin 13 and ground. So 13 and ground. Okay, sorry. We are just declaring the pin 13 because that's what we want to control. The ground is already there. So the ground usually you don't declare. So you declare only the port number. And that port number you use pin mode. So remember pin mode. It's a pin, then M is caps. And then inside you have 13, comma. You're going to have it as output, like that. So you have declared that port as one of your outputs. And remember, in this one we changed the resistance to 220. That way you allow enough amount of current to pass through to make this LED come on. Then, and avoid loop. You're going to want to put the LED on and off. So we do digital right, because you just want to put it on and off. Digital right. The brackets. $13, and then you have high. You delay for second, and 1 second is equivalent to 1000 milliseconds. So then from there, you put it off. I'll just copy that and I indicate this to be low. So digital write 13 low, which means you are sending no signal to the port 13. Otherwise, your program is done. You want to put your LED on and off, and after doing that, you just start simulation. When you start simulation, you'll be able to see your LED coming on and off. So on, off, on, off. If I vary this current, this value, like now I make it maybe 220 kilo ohms. It will make the brightness very low, which means so little current is passing through to make your LED come on. So we require the ohms. And if I change this value to maybe milliohms, it becomes so small up to a point where it shows that there's too much current passing through, and your LED will actually blow. It can blow. So you'll see there is basically a warning that's coming out. So you need to have ohms, 220 ohms. It's been calculated and found to be the most convenient value to use. So this is our digital output, which we can use, make it on and off, make it on and off, like that. You can even vary the amount of time it's coming on and off. Like now I can decide to make this one 100. What will happen? You actually have it blinking faster. So it blinks faster there, you can see. The faster blinking means that means you have your delay, which is much lower. In fact, if I were to reduce this value to 10, you might not even be able to see the LED blinking. So if I reduce that value to 10 and start simulation, I will be able to see it on throughout. Why? Because the blink rate is very fast. Our eyes are not able to detect that. And that's what is happening with this screen that you're using currently. The screen we have here for our display, it's blinking. The blink rate is quite high. Our eyes cannot be able to differentiate coming on and off. And even behind this, we have an LED, which will be displaying, we call the LCD. Of course, we'll be talking about that at some point. So that's our digital output, and that's how you can manipulate a bit the same. This is the device we are going to use to implement most of our digital outputs. So it doesn't matter what kind of output you're going to have. If it's digital that you want to just put it on and off, you can use the LED to model that. A door which is closed, open. Closed, you can say it's on. Open, it's off. Yeah, something like that. You can talk about even street lights on, off. Yeah. You can talk about aircon system on, off, and so on. You can talk about your mobile phone on, off. So, or your GSM module on, off. It's powered. Your Bluetooth module, same. Your Wi-Fi device, it's on or off. So that's what you can do with the first experiment of our digital. We call it digital output. Let's call it digital output. LED. So we can do another experiment next. our analog input, digital input. Let's work with the digital input first. So you can create new circuits. And you realize the moment you are doing this to your circuit, it saves automatically. So all changes are usually saved. Don't worry about that. And when you come later, you'll be able to access them. So I will need to do the analog input. We have the Arduino board. Then I have the that device there. Anyway, I have not started using the breadboard. Let us make our work easier a bit, so that later we can use the breadboard. So let's have our digital input. And this one, what you do, you connect accordingly. So please make sure that you have a resistor connected there. That one will just take it 1 kilo ohms, 1 kilo ohm, no problem. And this is how we are going to connect it. Terminal 1A will be connected to our 5 volts. Then we have it as red. Then our ground. So to our resistor terminal 2A, then to ground. I hope we are together. You need to be doing that. We are doing practicals virtually, but we'll be able to connect this one physically also. I will show you. So we take 2B to one of the digital ports. That will be our digital port, digital input. So you have actually connected the device. You can program it so that you can be able to see the value when you press and when you have not pressed. It works in such a way that when you press it here, there will be voltage here that will indicate a 1. When you have not pressed, it will show us a 0. So you go to blocks as usual, text, continue, and then you have your default program, which we need to change accordingly so that we can be able to do the functions that we require to do this time. So pin mode, we have one port, that is D2, which you have connected. So you can change this to 2. And then we have it as input because this time it's connected as a digital input. So please note that that's our digital input. But again, we are going to print the value in the serial monitor. So I can do serial dot begin because we need to initialize that so that it can be able to display for us. And this value here is supposed to be 9600, like that. So our serial monitor is initialized, and therefore it will be able to give us an output. Okay? So next we have we need to do something here now. We read the value. We need to read the value here. And please know that this will model so many devices that we deal with, very many. I'll be able to talk about that when we are done with the experiments, what it's modeling, the button switch. So what you do from programming part, which I repeated today, the IDE, you read the value int A, that's a data structure, and then digital read. So digital read 2, because You're supposed to be reading from 2. That's why we have connected our port. After you read the value, what you do, you print it. So we do serial dot print, and because I want to print the A first, so A is equals to, I can print it there like that. Then I come down, I print the actual value, which is given by A, or it's basically inside A. And this one I make sure I change it to LN. And then sometimes I would want to delay. I see the value appearing on the screen. So I can delay for 1000. That's for 1 second. That's our programming. I hope you've done it from your side. So start simulation. You have done the program. Check the serial monitor, and you'll see a value is printing A is equals to 0. A is equals to 0. A is equals to 0. Why I have not pressed on the button switch? The button switch is actually not pressed on. So what you do, when you press on the button switch, it changes to 1. You can see there, it changes to 1, 1, 1, like that. Changes to 1. So, but then you would want to use this 1 value somewhere, or 0. You can use it to control an LED. Like now I can want to, when I press this, the LED comes on. So in that case, you can connect your LED here, like that. And then, of course, put your resistor. You can change your resistor value to 220 ohms. As usual, to what we have in that device. But then we connect to the ground as well. We change the color to black. You have done your connection the way we did it earlier. Then now you go to the code. You need to do something about it. What are we supposed to do? We introduce the LED because it's a new device that we have added. We need to do that. So let's introduce the LED. The port to which you have connected it. So you copy, then you paste, and change this to 13. Then you have that as output. So within the program, we need to transfer that value that we read. If it is 0, the LED will be off. If it's 1, the LED will be on. So what you do, you digital write digital write 13 so digital write 13 then A, which means transfer the value that we have in A on port 13. So that if it's 1, your LED will come on. If it is 0, your LED will go off. So if you run the program, because you are reading 0, you can see there, the LED is off. But the moment I decide to press on that, the LED comes on. Why? Because we are transferring the value 1 to the output. We are basically transferring the value 1 to the output. And that's how we implement our digital input, digital output. So you're transferring the digital input to the digital output, just like that. So most of the devices which you actually have as digital inputs can be modeled using this. And an exact application for this one is the keyboard. You can see the keys you are pressing on. Please note that those keys are basically button switches. The power button, the power button will also be a button switch. You have on the mouse, the right and left clicks, all those are basically button switches. So they have quite a number of applications. And when we talk about them, this is how they are programmed in the operating system so that they can be able to apply that signal to the output accordingly, or from the input. Like now you can see my mouse, my cursor is here moving, but the moment I click, something can happen. So I click on that, you see something happens. I click on that, something happens. So I'm even using the hardware to control that as well. That is for the one which is the touch bar. It also has the right click and the left click. So that's what we have for digital input, digital output. And if we are getting an error, we need to sort it out. I think there's a way we usually sort it out. I'll need to stop my share, then you can share your screen. Yeah, so let's have a look at your where your error could be. Pin mode 2 input, pin mode 13 output, serial dot begin, int a is equals to digital read, serial dot print, serial dot printer n is right 13a, delay 1000, errors. Put a semicolon in line 5 to close the line 5. Yes, then now start the simulation. You can close and start your simulation. Should be able to work. So you press the button, just press on the button, we see whether it's working. Press on the button that you have, yes, that one. You press hold. Yeah, so it changes to 1, and that's okay. So you can stop sharing, then we continue. So I will do the next experiment, which is basically, now we deal with the digital, analog output and analog input. So those ones I can do them as another experiment also. Let's look at the analog input, create new circuit. And then pick your Arduino as usual, and then pick your analog input. These are analog inputs. And the analog output, maybe we can even connect them at the same time. So the analog input, we are going to use the buzzer, this one. So, and we can connect it somewhere there close to the this device, the Arduino. So the potentiometer is our analog input. The buzzer is an analog output. But you can also use the LED as an analog output by using the analog writer. So this one is positive, so you can just bring it down a bit and connect it to pin 13. Then you can pick the negative, connect it to ground. And that one, I think you can just have it as black. So our analog output is already connected to pin 13. So we know we have a device, the first one, which is connected to that port. And then we have the analog input, the potentiometer. Terminal 1 is usually connected to ground. And terminal 2 is connected to 5 volts. You can be able to change the colors accordingly. So we have this one as red. We have this one as black. And then this one, of course, goes to the analog input, because you are going to read our analog. So you connect it there. That's our analog input. So analog input, analog output. These are analog outputs. These are analog inputs, the potentiometer usually. So we do the coding. And pin 13 is already cleared. I will just need to remove this. But we need to declare also the pin mode analog inputs. So we have it as pin mode A0 as our input. Then serial.begin. And 600 as usual for our display. Then int A is equals to analog read. So this time we are reading an analog value. use analog grid. Remember we had that in the commands. And that's what I'm doing now. We're reading it from A0. So when you read that value, you can display it, serial dots, print, so we print A is equals to, and then down here we do print N, we have A. Like that, huh? And of course you can apply that value to the output. And how do you apply it? Tone. So we want to take the value we have read and we apply it to the output. And we use tone to do this. So tone 13, then we have comma, the value of A. So we'll be able to see the value which is digital, printed on the serial monitor, and then we apply it as a frequency to this device, that's the audio. So we are then going to have basically our delay, then we have 1000. So we start simulation. So I hope you guys are getting an audio from your site. Those ones who have done the program, if you are doing it, I believe you are getting the audio the way it's coming out. So you have your value printed, which is A, between 0 and 1023, because maximum will give us 1023, then 0 will give us, of course, minimum will give us 0, and that's how we get our analog input through our potentiometer. Please note that you can change this value to any other value. You can map it to range. Maybe I can like map it to range between, it can range between 0 and then 20, 0 and, so I can actually have int, because I would want to map that value, d is equals to tone 13A. It means you are applying a frequency of value A onto port 13. That's what it does. So you realize the moment you are varying, you are changing the potentiometer, it actually does the variation. That's a frequency. Tone is basically a frequency. And in your laptop, you realize it's also doing the same. The buzzer is actually making noise. I believe so. So I want us to do map. So we do equals to, and then we have map into brackets. You close. The value, okay, we could have done B anyway, no problem, but you have done D. I think, okay, it's fine. D, then A, comma, because we're having those values, we usually need to place them. A, 0, 1023 to maybe 0, 20,000. It will be able to change the value to 20,000. You can also be able to print it out, just like the other one. And then we apply that frequency. So this will be D. So you have D. And then that one is D. We are applying. Now we are applying a different range of values. And sometimes you can put this as a space. So I can just put a space between the values so that you can be able to see what happens there. So you realize it's now A 1023, D 20,000. So I can try to change that value to 0. It is 0, 0. I have maybe around 512, 511. It should be able to give us around 10,000. Yes, 9990. Yeah, so that's how you use the map function. And I think you guys now you've seen how we deal with the digital input, digital output, analog input, analog output. We have used the tone, but we have used also the map. What you have not done is the random. Random value, usually, I think you guys, you can just but that's what we have. And I would want to believe that I think what you have done is enough. At least you go and digest this. You go and redo them, then when you meet next, we continue. I think we'll still be continue with this practical. I will be showing you on how to do the, though for, I think we can be able to do the, I can be able to do the random. So here, instead of using read, I do random. And this value is between 0 and 1023. So I have it as 1024 so that I get that. Then it's able to print and it will map. So which means the input that we are having, the input from pin A is not working. We are only randomizing the values. So A random 0. So you can see it's generating random values now. Although the speed is a bit low, 1 second, but we are randomizing that. I think that's all that we have done, we were supposed to do today. I think that is good to go. I'll be able to share I will share the recordings. So bye-bye and good night. You guys, we meet next time.